Good evening, everyone, and thank you for joining us for tonight's presentation from Aspen Avionics on loss of control accidents and angle of attack. For those of you joining us for the first time, I'd like to welcome you to the SocialFlight community as well. SocialFlight is a free web and mobile app dedicated to supporting general aviation. We do that by gathering all the events happening in aviation, making them available at SocialFlight.com and through our mobile apps for Apple and Android devices. The events available through SocialFlight include our educational webinar series, which is why we're all here tonight. Our mission at SocialFlight is to bring the aviation community together and to give pilots like yourselves more reasons to get out there and fly. It's all completely free, and it's made possible by the leading companies in aviation, such as tonight's featured guest, Aspen Avionics. We're fortunate to have two presenters tonight. The first is James Buck, Director of Flight Operations for Aspen. James is a retired Marine Corps aviator with experience flying the CH-53 Super Sea Stallion helicopter, the T-34C Turbo Mentor, and many other aircraft that the rest of us probably only dream of flying. These days, James flies his own Cirrus SR-22, equipped, of course, with Aspen Avionics. Our second presenter is Ellis, Director of Advanced Technologies Research and Development at Aspen. Ellis is responsible for developing innovative avionics products capable of improving flight safety and to simplify key tasks of the general aviation. He's co-inventor of the patent-pending Aspen Evolution Angle of Attack technology, which will be explained in detail during tonight's presentation. A few separate housekeeping notes. A recording of tonight's presentation will be available on SocialFlight.com within a few hours, and we'll send you a link by email after the presentation to get to that. Sometimes it takes up till tomorrow morning, but we should have it up within a couple hours. Feel free to post questions during the presentation, and we'll have a Q&A session at the end. You can post questions both through the Q&A feature as well as directly on the chat tab. We will do our best to catalog those and prepare everything, and then we'll address all of them at the end of the presentation. So please stay with us to the end in order to get that. And one last item regarding audio. There are two ways to get audio for tonight's presentation. One is directly through your computer, and the other one is through the audio dial-in through your phone. We do recommend using the phone dial-in. It uses less bandwidth and generally gets you a better quality experience on the other end with less issues that come along with it. And that information should be available directly under the audio options section in the presentation in the left. But feel free to ask questions in the chat section. I'll do my best to keep up with you throughout that. And so with that, I will hand it over to James.
Thank you, Jeff. We really appreciate SocialFlight hosting of our first of what I'm sure will be many webinars in the future. Welcome to everyone out there, and thank you for taking the time to follow along this evening as you await the very important Powerball lottery numbers announcements this evening. And we look forward to answering any of your questions at the end. As you're aware, Aspen Avionics is an industry leader in electronic flight displays, and we're constantly developing new and exciting technologies to improve general aviation safety. Our latest innovation, software-derived angle of attack, is a game changer in both ease of installation and, more importantly, enhanced safety. As Jeff mentioned, I'm the Director of Flight Operations for Aspen Avionics, and I come from a military aviation background. I primarily flew the CH-53 Echo assault transport helicopter with 3 tours in Iraq. After my third tour, I was assigned to NAS Corpus Christi, where I instructed a T-34 Charlie. Here is where I learned and taught a lot about AOA-style approaches. November 123 Victor Golf, pictured here, is my personal family traveling machine as well. That's one of the aircraft used extensively during our AOA development and certification testing. I'm very lucky to have with me this evening Ettore Ellis as a co-presenter. Ettore's background in aerospace engineering is impressive, and we're very lucky to have an engineer of his caliber here at Aspen. As you can see, he has a master's degree in electronic engineering, a PhD in aerospace engineering, over 12 years experience in the international research projects at CIRA, which is the Italian Aerospace Research Center, which is equivalent to our NASA. He's currently Director of Advanced Technologies Research and Development here at Aspen Avionics. And as Jeff mentioned, he's the co-inventor of the Aspen AOA. So what's the issue? In case you haven't heard, the NTSB has made prevention of loss of control in flight type accidents its top priority. The prevention plan is based on 1, education, 2, flight currency, 3, pilot self-assessment, and 4, increasing situational awareness in the cockpit. angle of attack indicators, or AOA, have been used in the military and commercial aircraft for years and are a much better indicator of stall awareness than airspeed. Therefore, the NTSB and FAA are promoting AOA indicators for GA pilots in an attempt to reduce these types of accidents. So for our agenda this evening will be a bit more of introduction, then I'll talk about types of GA fatal accidents, followed by loss of control in flight type accidents in the pattern. After that, Etray will take over and go over AOA principles, types of AOA indicators, and how the Aspen AOA works. After that, we'll finish up with a few short videos of the Aspen AOA in action with Phil Boyer and his A36 Bonanza. A quick technical note, due to bandwidth, there may be some of you out there with slow connection speed, and therefore the video may appear jittery. I apologize in advance for that. You can always log on to our website later to see Phil's videos. Okay, so we already mentioned that loss of control in flight accident rates have caught the attention of the NTSB. It's important to note that 40% of all GA fatalities are due to loss of control in flight. And as we'll see in a minute, no other accident type comes close. The NTSB looked at the most deadly phases of flight, which are climb out, maneuvering, and approach to landing. Well, how many of you do one of these three things when you fly? This is what we do every time we fly. Now, it's hard not to start at the top of this chart, but let's go to the bottom and work our way up. A loss of control of the ground. These are primarily taxi accidents or post-landing type accidents. Low altitude operations maybe includes things such as flat hatting, or a new term I learned this past summer from a hunter called moose stalls, where hunters are flying low to the ground and they see a game they want to shoot later, and they wrap up and end up flying the aircraft on the ground. Running out of fuel, unattended flight into IMC by a VFR pilot, are other types of accidents that are out there. CFIT, controlled flight into terrain. If you think back on this one, it was pretty high up there 15 to 20 years ago. This number was reduced through advanced technologies like GPS, terrain avoidance systems, as well as synthetic or enhanced vision. Then finally, the reason we're here tonight, loss of control in flight, firmly entrenched at the top of the list. As you can see by the numbers, no other accident type for general aviation comes close to this, which is why the NTSB has a real focus on this at this point. So once again on this chart, let's start from the bottom and look at types of flying on loss of control incidents. Tying corporate and business flying together, these pilots tend to be better trained, have standard operating procedures that require annual or even semi-annual type-specific training, and generally fly stabilized approaches with minimal maneuvering down low. As for instructional flying, I can attest that new and seasoned instructors alike can get focused on training and lose situational awareness long enough for something benign to become fatal. Then at the top, here's the rest of us, flying our family to our favorite ski location, flying our kids back to college, or just in search of that $100 burger with a few friends that never flown before. Now on to commercial accident stats. But before I show you this chart, I want to go back 2 slides. And looking at these types of accidents for GA personal flying, what do you think is the top one for a commercial flying? It'd be fuel, component failure, CFIT. When we look at the chart, if you thought loss of control in flight, you'd be correct. So even well-trained professional pilots fall victim to this preventable type of accident. Okay, let's go back to GA flying. This is a chart from an NTSB safety seminar this past summer. As you can see, it breaks down typical GA pattern by number of accidents. Combining takeoff and initial climb, this is where we typically see the power-on type stalls. We'll skip over crosswind and downwind, and we'll look at the base, the approach, and finals. These are typically caused by not flying a stabilized approach, correcting only when pitch and power are needed, or overshooting final due to a crosswind. We have a real good video at the end of the presentation to show you how AOA can prevent this type of accident. Lastly, there is the missed approach IFR or go-around VFR type of maneuvers. In these cases, the pilot has made a good decision to discontinue landing, but somewhere in the hustle to change configuration ends up settling back into the ground or stalling the aircraft. This is where an AOA indicator, especially one with dual indicators like the Aspen, really shines. So there you are coming into land on speed with the AOA indicator parked right where you want it, nice and stabilized. Then just short of the numbers, you notice another plane pulling out on the runway. You immediately initiate a go-around and want to get away from the deck quickly and reach to raise your flaps. You remember from training to look at the flaps up indicator prior to doing so. You notice the flaps up indicator is up in the stall area, so you reduce AOA slightly to get that needle towards the green band prior to raising flaps. Becoming another loss of control in flight statistic has just been inverted. Okay, I'll hand things off to Ettore for now.
Thank you, James. Hello, everybody. So let's talk now about AOA principles. The angle of attack is defined as the difference between the airfoil chord line and the relative wind direction, or flight path in the air direction. The chord line is an imaginary line drawn from the leading edge to the trailing edge of an airfoil. The relative wind is the direction of the airflow impacting on the wing. In this figure, we want to stress how the AOA is completely different from the flight path angle, obviously, but also from the pitch angle. For instance, we could have always the same AOA of 10 degrees in three completely different situations, like climbing out, level flight, or descending. Stall always occurs at critical AOA. The critical angle of attack is the point at which, as the angle of attack increases, air will no longer flow smoothly over the wing. When this happens, the airflow separates from the surface of the wing, resulting in a drop of the coefficient of lift, and therefore in a drop of the lift, and finally in a stall. Stall always occurs at the same critical AOA, regardless of gross weight, angle of bank, load factor, attitude, CG, and above all, airspeed. Among others, one of the most important variables affecting the stall speed is the angle of bank. This is because for angles of bank different than zero, only a percentage of the lift is available for supporting the airplane's weight. The point to be stressed here is that the stall speed changes with the angle of bank, while the critical AOA doesn't. Now, James maybe wants to outline something on this table.
Okay, so let me jump in here for a minute. So what we have here on the right side of the display is a stall speed chart from a Cirrus SR-22. Now, when you fly a normal base to final turn in the SR-22, you transition from 90 knots indicated to 80 knots indicated in the turn with the flaps already at 100%. So if you take a look at the most AFCG 100% flaps down section over in the lower right, you'll notice that if you're at 80 knots, as long as you're below 30 degrees angle of bank, you have plenty of stall margin. But when you increase to 45 degrees angle of bank in an effort to save and overshoot, your stall margin quickly gets eaten up. And if you go even further past 45 towards 60, well, basically, if you're 80 knots, you're going to stall the aircraft. AOA systems such as the Aspen A will provide you advanced warning of an impending stall once you learn to incorporate it as part of your normal scan, IFR or VFR, and understand its meaning. Sorry, Ettore, back to you.
Okay, thank you. So, which are the AOA device styles? There are three main styles of angle of attack devices. The first is the vane style, mainly used in military and commercial aircraft. The vane rotates to align with the relative wind, and the position of the vane itself is a direct measure of the AOA. Another style is the differential pressure one. In this case, the AOA is calculated from two pressures measured by a dedicated probe. Finally, there is the software-derived style, where the AOA is calculated by using measures typically already available in a display, and not from dedicated sensors to be installed. The Aspen AOA is a software-derived device, and we are honored to have received the Flying Magazine Editor's Choice Award for this product.
Well, let me jump in here real quick again, Ettore. I spent most of last spring and summer flying with FAA test pilots and a lot of press customer demos in my Cirrus. I noticed that when walking up the plane, everyone was looking underneath the wings and then back at me. I had to chuckle and tell them there are no hidden AOA probes under the wing. Their common question was, how can you do this with just software? My response, it's rocket science. And since we developed this with Chira, this is a true statement.
Okay, right, thank you. And I will say something about that in the next slide. The Aspen AOA uses measures already available in Aspen space, as we said, like accelerations, gyro rates, GPS ground speed and track angle, true airspeed, indicated airspeed, and climb rate. So as you said, very often we hear the question, how can it work? Well, we developed in collaboration with Chiron a proprietary algorithm, and in simple words, it is an aerodynamic model of the aircraft that we feed with different information. Firstly, the measures I have just mentioned, but also information gathered during the calibration flight, when we basically learn about the lift profile of the specific airplane. Finally, the parameters collected from the POH of the specific aircraft, for instance, the stall speeds. By means of this model, we can calculate the angle of attack, but also we can calculate the side slip angle and the wind components. For this reason, our AOA is not affected by high angles of bend or by high side slip angle conditions, like many other devices based on direct sensors. Now James will illustrate some AOA in action situations.
Okay, so before we start videos, let me remind everyone what we stated earlier. Depending on your connection speed, the video may or may not work for you. However, all these videos are available for viewing on the Aspen Avionics website, as well as YouTube, and the YouTube address will be on the very last slide. I believe also Jeff mentioned earlier that the entire presentation will be available for review afterwards. A few other notes before you break out the popcorn. What you're currently seeing, and I'm going to use the cursor here, what you're currently seeing is the Aspen AOA on the PFD and on the MFD. You have the option on the PFD to basically have the AOA displayed all the time or have it in auto mode. In auto mode, the AOA only comes up when the software determines you need it. There are three other views of the AOA and the MFD. We have, if you're familiar with our products, we have the thumbnail screen, so you could have a small AOA indicator in the thumbnail box up here, or you can have it down at the bottom screen as well. You'll note that the AOA indicator has 4 color bands. Primarily, I want to talk about the green and yellow transition area right here. Is typically where you'll see the needle parked for a short field approach, which basically approximates VS or VSO times 1.3. The yellow and black cross-hatch area up here is typically where if calibrated properly, is typically where you hear your stall warning will go off, and then right at the top of that is where the aircraft would stall. There are 2 wedge-shaped indicators. The top one represents the flaps up, and the bottom one represents the flaps down. Depending on the aerodynamics of your particular airplane, the needles can be closer or farther apart, but the flaps up indicator will always be above the flaps down indicator. Okay, so this is the first video of Phil Boyer. He's conducting a normal approach in his A36 Bonanza at his home airport in gusty conditions. Since he has full flaps configuration, he'll be scanning the lower indicator while primarily looking at his book airspeed. As you can see there, that needle is kind of bouncing around the green-yellow transition as he's coming into land, flying his book airspeed. It's important to note here that you need to fly your book airspeeds and use AOA as supplemental information. For my military folks out there, this is not the same as flying an AOA approach to a carrier where you reference only the AOA and the external visual cues from the ship to conduct an AOA landing. It's important that GA pilots fly the book airspeeds and reference AOA indicator for stall margin. Now remember back to the stall speed chart I showed you. Stall speed increases with angle of bank. Okay, now Phil's going to show us what a short field approach looks like. He just did a normal approach in that one, and this one's a short field approach. He's going to be a little bit slower airspeed. And he's in the landing configuration, so once again we're referencing the bottom indicator, the flaps down indicator. Note while he's flying that the flaps down indicator is modulated on the green and yellow transition. He's flying his airspeed, but kind of cross-referencing the AOA indicator to maintain stall awareness all the way down. And for a multi-tube customer, you'd probably have only one AOA indication up, maybe on your MFD. But if you're a single-tube customer, and that was one of our primary concerns, we want to also offer an AOA indication for our PFD-only customers. Here he comes in. He was able to maintain it pretty well right there at the green-yellow transition. Okay, in this video, Phil has a bit more altitude. Is going to demonstrate how the AOA works during a landing configuration stall. Note that once again, we're looking at the lower flaps down indicator during this maneuver. As the aircraft slows down, the lower indicator slowly moves up the green indication, the green band, excuse me, past the green to yellow transition. Now here it's important to note, if you see that indicator in the yellow transition, in the yellow band, this is where you should already know something's going on. You need to reduce the angle of attack. It's getting slower and slower. The stall horn goes off right about there. And right there you can tell the aircraft brakes, and that's a stall. So remember, the key takeaway on that video is when you see that indicator, the flaps down indicator going up the yellow band, reduce your angle of attack and recover early. Now on to a takeoff and VY climb in Phil's Bonanza. Since he's in clean configuration, we'll now be looking at the flaps up, or the upper indicator. If you look at the slide, a good thing to mention here is the PFD is currently in AOA auto mode. So right now the aircraft's on the deck, the system does not see the need to have AOA displayed. But once airspeed starts coming alive and the aircraft starts rolling down the runway, you'll note that the AOA indication automatically pops up without any pilot interaction on the PFD. Also note on the MFD, while the AOA is not needed, the needles aren't there. The AOA band is still there, but the needles aren't there. So once the aircraft starts rolling down the runway, you'll see the needles appear from the top and start working their way down. It's also important to note here that AOA cannot be used to decide when to rotate. You can see as the needles as you're starting to go down here, the needles aren't in view, and there they go. They pop up and start scrolling down the band as the airspeed increases. Once you're out of ground effect and start climbing, you can see though, as he's working towards the VY, you can see this would be an excellent indicator that would prevent those power on stalls we talked about earlier. So he's slowly increasing his speed. I believe VY in his aircraft is right around 97 knots. And once again, we're looking at the upper indicator, and lo and behold, look, that upper band is parked right there at the green to yellow transition, giving him about roughly a 30% stall margin. Okay, so once again we have Phil back at a safe altitude to demonstrate how AOA works during a power on stall. This is in clean configuration, so we're going to be watching the upper indicator. Note that as the AOA and flight path angle that Ettore talked about earlier gets larger, the upper needle slowly works its way up through the green band, then slowly into the yellow band. Here he's going through the transition. Note also, if you look at the PFD really quick, you'd see the red chevron of the attitude indicator. That's another great tool that Aspen offers to let you know you're at excessive pitch angle and push the nose down. So there it is up in the crosshatch area. Stall horn has already gone off and the aircraft just broke right there. So once again, if you note the appropriate needles moving up into the yellow band, you need to reduce your angle of attack back in the green band to maintain a healthy stall margin. Now these last two slides are very important. This first one shows what a normal base to final turn should look like. Note that throughout this maneuver, is base to final turn, Phil does not exceed 20 degrees angle of bank, or it doesn't exceed 30. I think the most you'll see during this turn is 20 degrees angle of bank. He's in landing configuration, so we're looking at the bottom needle once again. And that bottom needle, as long as he's flying his book airspeeds, that bottom needle is going to stay in that green area. There is rolling out on final, and with plenty of stall margin, so very well executed. So here's the base to final, the infamous base to final overshoot. and what the Aspen, and how to look on the Aspen AOA. What Phil's going to show you ever so briefly is what the AOA is going to indicate if you overshoot final, then try to salvage it. Since he's in a normal pattern this time, he won't roll much past 30 degrees angle of bank, but it's more than enough to show you that if you keep AOA as part of your scan, even if your airspeed seems okay, you'll be able to detect quickly that you're running out of stall margin and need to do something to correct it. So here he is. Once again, he's in the landing configuration already, so we're looking at the lower needle. The lower needle's down there in the green band. He's right now just about 25 to 30 degrees angle of bank. Everything's still looking really good. He rolls off for a second and getting ready to turn his base to final, and he realizes he just overshot. So he wants to impress his friends and families and not do a go around. So he's going to try to salvage this. Now watch him roll to 20. There's 30 degrees angle of bank, and look at the lower needle is already at. It already shows him at this point that he's lost his stall margin and he needs to reduce his angle of attack to get it back down the green. So as long as you learn to incorporate this in your scan, this is going to be a very effective tool. Well, we wanted to keep the presentation part short because we know we're going to have lots of questions, so we appreciate your time this evening. The Aspen Avionics to Ride software has been certified since July of last year. It's been a very popular option for our customers and has been very well received as well. For current Aspen customers, it's a simple software update followed by a short calibration flight that is now down to about 5 minutes from start to finish. It's important to note, aside from the benefits pointed out in the videos, that due to our unique approach, the AOA indicator is unaffected during slips or crosswinds, which is not always the case with other systems, depending on where the external probe is located, as Ray mentioned. With that, I wish you good luck on Powerball, and I'll turn it back over to you, Jeff.
Thanks so much, James, and Ray very much. And just to everyone who's in attendance, you can feel free to submit any questions you may have. We have a few that have already been put in there, but using either the Q&A feature or directly on the chat. I'll give my own kind of personal experience having to do with this. I'm a big fan of angle of attack systems, and I kind of had my own learning or teachable moment a number of years ago in my Bonanza as we were climbing out in instrument conditions, IMC, steady climb out, and with just the workload and looking to figure out what was going on, I just noticed that I kept having to increase my back pressure in order, and it may have even been the autopilot at the time, in order to get the rate of climb that I was looking for. And it wasn't until I started to hear the chirp of the stall warning go off that I realized I was in a very steady, sustained, and calm downdraft. And so it's very easy without, even in phases of flight that are not in the landing pattern, to wind up in situations where angle of attack can really, really help. And since that time, I've certainly been completely sold on it. So very, very excited to see what we have tonight from everyone. So that's just my personal experience on that. We have a few questions. One of them is, we haven't seen anything about alerts, audio or otherwise. Can you talk about that, James?
Well, our system, we really worked hard on our system. We thought long and hard about audio alerts. And there are a couple of our competitors out there that have audio alerts. When talking with those customers, they typically find it to be a nuisance, and they'll turn off the audio alert anyway. And plus, the big thing with the FAA and certification is nothing we did could counter or be misleading when it comes to the onboard certified stall system. So we worked very closely to get our system to work in conjunction with your onboard stall warning horn. That's why that yellow-black crosshatch area, right around that area is where your stall warning could go off. So you visually check your AOA throughout the main maneuver. If for some reason your scan is slow and you miss the visual indication, the stall warning horn should still give you enough notice take a quick look at AOA and say, oh yeah, I really need to reduce my angle of attack. So we found that the audio really wasn't a necessary addition. I know a lot of people want it and swear by it, but we found the vast majority of folks that already have it have in different systems have turned them off because for a nuisance. If you think about it, every time you land, something, because you're landing at that, once you transition to a normal flared landing, your AOA indicator is going to go up. So every time you land, you have some type of warning going off in the cockpit. My wife, I have a DSC-90 autopilot, and every time I land, it gives me all sorts of warnings. It drives my wife and my passengers crazy, so I'd really prefer no extra. I don't like the extra warnings.
It certainly makes sense. Another question, we've gotten quite a few questions about installation there. Could you talk a little bit more about how it works? Obviously, you said there's no real hardware if you already have a Aspen EFD 1000 PFD or MFD, but what's involved and how does this work as far as calibrating or anything else that's required?
Well, so you go to your authorized Aspen dealer and you get the software upgrade. He loads basically, it's the same thing as your nav data card. He loads that nav data card with the software on into your PFD or MFD. He puts in a couple parameters. We need to know your basic empty weight, your max gross weight. Really important, the weight the aircraft is going to be when you calibrate it, and a couple speeds that it pulls off your the EFD anyway. And then after that, you go out, you climb up to a nice safe area. You press Start Cal. It'll tell you, okay, fly clean condition at a certain airspeed that it calculates. So say fly clean at 132 knots. You press the start button, you fly that for about 30 to 45 seconds. As long as you were able to maintain straight and level flight for 30 to 45 seconds, it's gonna move on to the next step. If you had trouble maintaining airspeed, if you got typically if it's a bumpy day and you got bounced around and you lost and you had a lot of pitch changes or altitude changes or roll changes, it'll tell you it's not going to accept that. You need to do that step over again. So then once you go to the next step, it's once again another clean configuration calibration point. Now it'll tell you to fly whatever airspeed it calibrated that it needs to determine your angle of attack profile. And so say in this case in the Lance, you fly, now you're going to fly clean at 86 knots for a minute and a half. You press start, it counts down. Once it's done, once again, as long as you maintained a decent control of airspeed and altitude, it'll move on to the next step. And the next one is really important. It's going to ask you to configure the aircraft in your landing configuration, so gear down, flaps at 100%. It's going to tell you to fly another calculated airspeed that it determined it needs to determine what your angle of attack curve is going to be. And that's when you fly for about 30 to 45 seconds. Once again, maintain straight and level flight. Everything's good. It tells you at the end, calibration is successful. You restart the MFD, and you're done. And you never have to recalibrate it again.
Very interesting. That certainly makes sense.
And basically, from the time you hit start on the first calibration point to the time you're done is about 5 to 10 minutes. It's pretty quick. And you don't need to go land, adjust the angle of the probe, go back out again, do another test run, go back land, adjust an angle of the probe. So the calibration is not only is installation so much easier, the calibration is much easier as well.
That's great. Now, we have had quite a few questions about people asking about the concept of the two indications for flaps, and they're trying, I think, to take some information that they have with other types of systems out there, including vanes, and compare that to having two presentations of flaps up and flaps down. Any information you can give us on that?
Yeah, we basically have two needles for the two situations because we don't have the measures that says us if we are in flaps down, flaps up. But having two needles, we also thought that was an interesting feature actually because it's a kind of predictive information you can get. For instance, if you are in landing configuration, you are climbing out, you look into the needle related to flaps up, you will know what happens to your AOA if you retract your flaps. So we actually think, also FAA said that that is a very interesting feature. So having two needles from this point of view is better.
Yeah, if you look at an OEM type installation, we'll take the T-34 Charlie, which I flew, for instance. It's a vane style indicator. It's installed during the manufacturing process. It's not an aftermarket product. There is a computer in there that knows whether what conditions the flaps are in, so it makes an adjustment based on that. The other systems out there that are pressure derived, they don't know whether your flaps up or flaps down either. And so what they do, if you do the calibration correctly, you're supposed to calibrate those in the clean configuration. That way, when you're in the landing configuration with the flaps down, you have a more conservative AOA. But we feel you lose that conservative, depending on the aircraft, that you can lose a bit of angle of attack that you're unnecessarily not willing to give up for a short creel approach. So, and the question about the flap indication, if you look, so our two test aircraft are perfect examples. So I fly a fairly modern SR-22 with electric flaps. Our primary test aircraft is a 1979 Piper Lance with a flap lever, so it has no electric flap. So there's no way for you to tell whether the aircraft is in flaps up or flaps down configuration, unless you go through and do some very expensive modification and wiring on those aircraft that don't have electric flaps. So since we have a very large AML of aircraft mixed with manual flaps and electric flaps, we just opted not to worry about the flap indication. Now, we first developed the AOA software. We didn't really think about the flaps up or flaps down. We were going to calibrate it like everyone else in the clean configuration. But through testing, we found out that our system is so much more accurate. And so if we just go with two needles, we give the pilot much better, much more accurate information depending on the configuration they're in. As Ettore said, if you're doing a wave off and you're pitched up and you're getting ready to clean that aircraft up, you transition from the flaps down indicator to the flaps up indicator. You can see that if I raise my flaps right now, I'm going to be stalled. So it's a very good predictive indicator in that type of situation. So we're really proud of it. We like that.
Very interesting. Can you talk about it? Is it essentially kind of two separate systems if you have a multi-tube Aspen system, or how does that work if you have an MFD and a PFD?
So if you have a PFD 1000 and an MFD 500 combination, the MFD 500 takes the AOA data from the PFD. But if you have a PFD 1000 and MFD 1000, now remember the MFD 1000 has a reversionary capability to go into a PFD, so it has its own separate AHRS. So you have to calibrate both of those.
But you can easily do at the same time.
Oh yeah, we do them at the same time, and it's very easy. It works out really well.
Okay, and certainly we've got a few questions here, but you know, there of course are going to be attendees here that are not Aspen customers yet and don't have one of your products, and so I assume there's no display in any other way. That basically this has to come with the products themselves.
I'm sorry, could you rephrase that one more time?
We've gotten some questions from people that currently do not have Aspen systems, and so they just want some clarity on the AOA system, and that it's, you know, obviously it's not separate from your products. So certainly someone has to be purchasing what, at minimum, the PFD.
Oh yes, I'm sorry. Yeah, so the minimum you need for our system is a PFD, and if you recall back to Phil's videos, the PFD was shown up there. It's up in the upper left-hand corner, just inside the airspeed tape.
Okay. And what information is actually needed at the time of installation? Is it just the weight, the empty weight of the aircraft and the gross weight of the aircraft?
So you need the basic empty weight, the max gross weight, and then what's really important is the calibration weight. And I could probably let Ettore talk to that some.
Yeah, these three weights and some speeds. The source speed for the VS, VSO, so for both configurations of flap, and the VNO and the short field approach speed. These are the parameters we need during the installation.
And it's pretty simple. Any authorized Aspen dealer can quickly go into those menus and change all those things. It's important to note, and it's also important to note the customer, since this is a certified installation, the installation has to be done by authorized Aspen dealer. The calibration flight is done by the owner. And typically, it's a good idea to take the installer along with you to make sure everything was done right, and you get a logbook entry for the installation after that.
Excellent. Good, very, very, very good information. And the last question that we have of the evening is, are there any outputs of this? People have asked, can it display on an iPad? Can it go to an external indicator, anything like that?
Currently, at this time, we don't have any plans to output that to any external displays or anything like that. But we're always working on new stuff in the future, and so if we see there's a big demand for that, I'm sure we'll take a look a little closer at it.
Great. Well, again, James, thank you so much for your time tonight. Thank you, Ettore, for joining us as well. This has been a very, very interesting presentation, and we really appreciate your contributions to making this part of SocialFlight's webinar series. And we would invite everyone in attendance to please join us for some of the other presentations that we'll be having as part of this series. From, again, some of the leading companies in general aviation, and Aspen certainly leading the pack there. So thank you all so very much. There will be a recording of this presentation available by tomorrow morning. You'll get an email with a link to that following this presentation. And as always, just go check out SocialFlight.com or the SocialFlight apps in order to get all the information on where you can be flying and what you can be doing to help support general aviation. So thank you all so much, and have a wonderful evening.
Thank you.